Hi guys, you welcome back to my channel. In today's episode of our general positivity past question and answer, so today we'll be looking at a question under organic chemistry. Just two questions under organic chemistry. The first one goes thus: we have this equation. Mind you, what you have here is called acetic acid, or we call it ethanoic acid under the carboxylic acid reacting with zinc. What will be the product? The first option is we have this, we have this, we have. So let's take a look at how we can easily deduce our answer and see which one is the correct answer. The first thing we have is what? 2. As I've said earlier, this one is what? Acetic acid, or you can call it acetate. Anyone you want to call it, plus zinc. So there's one thing you need to know, that if you have to balance this equation, this zinc here is going to displace the hydrogen here. So by doing that, we call it a single displacement reaction. In case I ask you, maybe you are not to pick the answer, but rather they ask you that what type of reaction exists here, it is called single displacement reaction. Now, how does this zinc here displaces the hydrogen here? Mind you, if I have this here is what? Is 2. So now I can decide to just put it like this. 8. Now it has represents the 2 of the ethanoic acid. Now this again is going to what? Displace it. That is, if we are to displace this hydrogen with this zinc, meaning we are going to what? Eliminate this out of this place. By doing that, we have hydrogen gas. So return this back to this. We are left with what? We have 2H3CO what? This one is called the ethanoic acid, that is the esters. So we are going to move this on to this place. So we have 2CH3COO, then you put your zinc here. But in other way, you can say you want to write it like this: CH3, open a bracket, COOH. So we have your zinc outside, we have 2 here, plus hydrogen gas. So you can call this zinc acetate. And don't forget that the reaction that exists here is called single displacement reaction, because the zinc here displaces the hydrogen. So I advise you that we should go with this instead of what? This, in case you come across it. So you should know the answer you have to pick. So let's go back to the option you have here. So looking at the option, this no, this no. So our answer is what? C. So let's clean this out. So this is our answer: zinc acetate with hydrogen gas. Now the last one says, when potassium hydroxide is used instead of sodium hydroxide in the production of soap, note one thing: this one is soluble in water. I'm not saying sodium hydroxide is not soluble in water, but this potassium hydroxide is what? Easily soluble in what? Water. So it has the following advantages, except it gives. One thing is, the advantage of using potassium hydroxide in place of sodium hydroxide is that we are not going to have what? A softer soap. Rather, we are going to have what? Harder soap, because this potassium hydroxide here have eyes, we call it the melting point of a specific rate of a compound. So by doing that, when potassium hydroxide is being replaced or is used instead of sodium hydroxide, and the state is clear that it has the following what? Advantages. In case you come across it as a student who is willing to sit for the forthcoming post-UTME, your answer is harder soap. So guys, don't forget to subscribe to my channel, like, share among the community, be it on YouTube or our TikTok page. Thanks.